Hi everyone. I already see someone is in YouTube. Ewing and Karen from Shania. We still have 2 minutes before we get started. Okay. We still have 1 minute. Hello everyone. Welcome. Well, sorry. Hello everyone, welcome to our third lesson for our SASMO preparation. Yeah, we still have the one last minute before we get started. Oh, so excited. It's a long journey, right? I just got some parents that, oh my god, the lesson 2 is so hard. I have to say no worry about that because in this preparation course, I'm trying to give you all the possible frequently tested knowledge points. So, obviously, not every question will be tested in the SASMO, but if we prepare more, the kids will have more possibility to get a gold medal. Okay, it's just 5:30. Now, let's get started for our today's third lesson. What are we learning? We are learning today about some countings, some combinations. So there is a very big difference compared to what we learned the first and second lesson. There will be no such clear rule step by step by step. Because all of this question is trying to test you critical thinking skills. So each time you definitely will see a totally different question. But there will be some similarity. Everything they test, the basic is the same. So let's get started. First one is about counting. Counting is a very classical type of question, right? Even you are in kindergarten, you already start to count one by one, one by one. But what is the tricky part? For example, this question: how many rectangles are there in the picture? Okay, counting is a really interesting point, which can distinguish whether this kid have already learned Olympic math or not. Why? For the normal case, if you haven't learned anything about Olympic math, what will you do? Maybe you will count all the rectangles one by one. It's quite normal. That is what we learned before, even in our K2. But if you are skilled, if you learn some skills, you will do it faster and avoid casual mistake. For example, I give you the first tip: count by layers. Instead of a count one by one, you will find there are some big, there's some small rectangle. For example, this one is the rectangle, this one is also. How could we distinguish them? No worry, let's try to slow down. Firstly, let's check in this question, just in this layer. First layer, there are how many rectangles inside it? 1, 2, 3, 4, 5. Is that enough? No. In this case, actually it involves another knowledge point called shooting method. How could we count in 2D shape like this? It's original from how could we count line by line. In this case, if you are the first time to hear about this new concept, I teach you a much more easier one for you to calculate. Firstly, let's calculate how for each layer, how many rectangles are there? Only one. You will get from this one, 1, 2, 3, 4, 5. There will be 5. But that is all starting from this line. How about from this point, this line, we will go, there are 1, 2, 3, and 4. See, each time like a shooting method. Sorry if I keep writing, this picture will be so ugly. So I just stop here to show you. In this case, if you keep going, the next one is starting from this line and counting each rectangle, there will be 3. From here, there will be 2. From here, there will be 1. Why each time it will decrease 1? Because there will be 1 more or 2 more or 3 more rectangle we already counted in the previous one. So first layer, we will get 5 plus 4 plus 3 plus 2 plus 1. So in this case, if you know some tricky part, you can even calculate faster, because 1 pair with 5, 4 plus with 2, and then you will get 15 is for each layer. So I notice 1 layer, 2 layer, second layer, I know it must be 15. I even don't need to calculate it. Sorry, this is too ugly. Second layer, of course, it should be the 15. Everything is the same. Why not? Right? So our final answer here, it should be 15 times 2 equals to 30. Is that right? Everyone? Okay, 3, 2, 1, right or not? Come on, if you think it's right, you ignore something. Because when we count layer by layer, in the rectangle, small rectangle, you notice there will be 1 more rectangle. For example, the blue one consists of 2 little rectangles. But how about the big one? How about we taking layer? This is 1 layer, 2 layer. How about we take this one as a big layer? Combine the layer 1 and layer 2. So there will be our 3rd layer. That is the big one. How can we get our 3rd layer? Combine the first 2. So actually, our final answer is not 15 times 2, but 15 times 3. We got how many in? Everyone, it's a very easy calculation. I'm pretty sure everyone can do it. So in this case, we can got 45 as the final answer. Okay, just in this question, if you want to take notes, just write down count by layers. Layers by layers. It will be very easier for you to do this question. Okay, next question we will see. In computation, how the different level question arranged. Next one, level 1 up. Are you ready for that? Let's go. Okay, everyone, just tell me, what's the difference compared to the first one? Okay, firstly, we'll notice it's quite similar but sometimes different. Firstly, we got now 2 layers, but 3 layers, 1, 2, 3. Secondly, each time it's not 1, 2, 3, 4, 5. It's 1, 2, 3, 4. Each column, there are only 4 columns. And if you are very smart or clever boy or girl, you will notice it's not a normal rectangle layer by layer. There's a little annoying line, just like here, just stand here. Do you like this one? No, I really don't like it. Just because we got this little line, make this question so complex. How can we solve it? I have a suggestion. How about we just forgot it? We don't care about it. And we just checking all the rectangle before and then come back to this little line to see, because of this little line, how many new rectangle we get from that. Okay? If you agree with me, let's do it. Just firstly, ignore this part, and then checking 1, 2, 3. It's the same as we did before. We're also checking this question layer by layer. First layer, how many rectangles are there? In this time, I think you don't need to count it one by one. I already showed you the basic method. So for the first layer, For the first layer, there will be 1, 2, 3, 4, 4, 4 plus 3 plus 2 plus 1. How many are there? There will be 10. Each layer, oh, I should write down each layer. You don't need to count it one by one. The next question will be, how many layers are there? Is that 1, 2, 3? Just 3 layers? No. Remember the previous one? When we count 1, 2, you know, finally you should combine the 2. So in this case, how many layers are there? The number of layers. I think I should write it down. Number of layers in these questions is now 3. Instead of that, we got 3 layers for each. But how about we combine 2 layers together? We got 2 more. Like the ACGE and BDHF. That is 2 more layers combined with 2 little layers. And the next one, can we have found one more? Exactly. We can find ADHE, this big one, we can take it as a whole layer. So finally we got 6 layers. How many rectangles are there? 6 times 10 equals to 60. If we ignore this little line, there will be 60 rectangles. Just a perfect number. How about we add one more line? Yeah, in this case, it's like a basic shooting method. Just original from this little line, how many new rectangles can you get from the question? Let's do it. For left side, 1, 2, 3. Okay, down. For the right side, 4 and 5. How many more? 5 more. So 60 plus 5, we got 65 layers. That is our final answer. So in this question, what can we get? Some of the time when we see, oh, that is a really strange shape, no worry about that. We can just take what we are much more familiar with. Find the basic structure of the shape and then try to determine how many rectangles are there. Okay? And then when we go back to deal with the last one, that is a basic ability. We try to remove it and checking for how many shapes are there. How about for next one? This one just show us a different idea, but a similar thinking method. What is that? When you see this kind of shape, what is that? It's a regular pentagon, right? But it's not a perfect one. Why? We are lacking of one more line connected. If we can connect there's 2 vertices, that is a perfect shape. However, we don't have that. What can we do? How about we just add that one more line. In the previous question, we ignored that. This time, we add it and finally just deduct all the shapes could originate from that. And now, once we finish this part, you're almost done. You already found the most tricky part. Next part, I wish you can find out how many triangles are there in the picture, but I want to ask you, how many different size of triangles are there? How many different size of triangles are there? Okay, so I leave you 30 seconds. You can check this figure and tell me the answer. I can really wait for you for 30 seconds. Because I already told you one secret. The next secret, I wish you can find it by yourself. Okay, yeah, is there anyone found it? Whoa, is that so hard? No one know that? Oh, 20 seconds. Maybe some of you directly gave me the answer, but wait a moment. There are many methods we can get the final answer. But I just want to teach you the clear way. Okay, are you ready? Are you ready? Someone told me there are 3 different types of the triangles inside it. Now, let's check how many different types of triangles are there. In this case, my question is really interesting. How can we find how many different types? The problem is how many different sizes. Is how could we determine the size of that? How could we make this classification? Here we go. Let me show you this picture. Exactly, there will be 1, 2, 3, 4, 5, 6. 6 different size of triangles. Check which one you lose. I'm pretty sure that for the this one, the first, second, third, you will sound, oh, they are the same. They are the same. However, someone may be curious, why Teacher Charis, you put the fourth and the fifth one as two different triangles? Okay, that is an interesting question. For this question, for example, I take the first one example. If you want to count how many are there, how many? 1, 2, 3, 4, 5, right? 5, this kind of little rectangles are there, triangles are there. But if you remember, review how you find this little 5 triangle, why is that so easy to find out? You will find you're checking each triangles by the vertex. Similarly, we can check this one, and you will find there are two more interesting parts. We're checking 1, 2, 3, 4, 5. 5 different vertices, so 5 outside. How about for this one? This one is slightly different. Is that also 5? Is that also 5, everyone? Is that also 5 here? This one is the only one tricky triangle among all of them. Because this one not only have 5, instead of that, it have 10. Why? Let me show you. Because the previous one, I can use only one vertex to determine where is this triangle original from. But for this one, if you determine this one as the vertex, you will find from this one you can find exactly 2 of that. 2 of that. Even you find from this one, you also can find 2 of that. So for any vertex in this triangle, you can find 2 similar triangles of that. So in this case, we got 5 times 2, there will be 10 rectangles. 10 such rectangles here. Lastly, I'm pretty sure count these 2 triangles is not hard for you. The only one problem is why we will distinguish them as the 2 different triangles. Even they look like so similar. But the problem is that are they really, really similar? Maybe, but personally, I do not suggest you to think so. Because previously, every time we are checking each triangles by the vertex. We can still using the vertex to check it, this one, and obviously it's the outside triangle. Outside. And this one is the inside. Okay? Each of them also have the 5 triangles. Lastly, this one is so easy. You can also check in the vertex or by the size. There will be also 5 triangles are there. So in total, there are how many triangles? Sum of them equals to 5 times 7 equals to 35. But is that 35 our final answer? No, not right. That is the reason why I picked this question. Don't forget, initially, why we can quickly calculate all the triangle in this way? Because we assume it's a perfect regular pentagon. But if I cancel this line, how many triangles will deduct from the shape? Obviously, this one. And for the size, for the triangles outside, 1, 2. How about the smaller one? Smaller one, you will pick, there will be 1 more, 2 more, okay? So actually, once you deduct all the repeated triangles from the last line, you will minus how many? You will minus how many? You will minus exactly 6 of them. 6 of them. If you're not sure why 6, does that mean 6 because of we got six classification here? No, the tricky part is for this one. From this side, there will be two similar triangles inside it. So actually when we deduct, I count two of it. And the rest of them, just count it one by one. I'm pretty sure you can get the final answer. Okay, so the final answer for this question is 29 triangles. Once again, from this question, it can give us two hints. Firstly, we no longer count the shapes by layers. We are counted by size. Secondly, when we found some of the shape is very strange, we can try to add or remove some line, some part of it, and finally come back to fill it or deduct it. Lastly, for this question, it's actually easier compared with the previous one. Why? Because we don't have any annoying lines here, right? How many triangles are there in the picture? Checking it layer by layers or size by size. Actually, I gave you the tip, count by size, but you can have a try. I allow you to have a try. If you really want to check the triangles layer by layer, you will find later you cannot directly times everything. Why? Because the previous one, every rectangle, they are perfectly stand here. However, for the triangle here, you will find some of the triangle is not a regular one, it's rotated. Some is big, some is small. So in this case, instead of we checking all the triangles layer by layer, we're checking it by size. How can we determine it by size? Similarly, we will use the same technique as we learned before. Firstly, we will checking all the triangles. The size is the one layer high. Why I use the high? Because which means this triangle, this smaller one, only have taking one layer as the height of it. Okay, similarly, clever boy and girl, think about, I can also classify the size by two layer size, this one, and then three layer, and then four layer. Among 1, 2, 3, 4, do you know which one is the easiest one to find out how many triangles are there? Of course, the fourth layer. There's only one big triangle, consists of 4 layers. And how about we come back? The 3 layers only have 1, 2, and 3. Can I find any others? No. Even the rotated, no more. It's not allow you to rotate it. So there will be 3 triangles with the 3 layers. How about for the triangle with the 2 layers height? This one we really need to calculate it. Because it's not so easy for us to find out them. Firstly, from this part, 1, 2, 3, and then 4, 5, 6. Is that all? No, you will find there are one more rotated 2-layer high triangle. So in total, there will be 7. Lastly, for the 1 layer, this one is so easy. It's the classical one. You just need to count it one by one. It's okay. So you will find in total, there are 16 little triangles. Have the 1 layer high. So let's find the sum of them. The sum of them equals to how many? Let's check it. The sum equals to 16 plus 7 plus 3 plus 1. Final answer will be 27 triangles. Congratulations! That is everything for our counting problems. For the counting, it's not so hard, but it's also sometimes not so easy. I already show you in the SASMO competition level what might be the hardest part. It cannot be harder than this one, okay? So once you handle this basic idea, I'm pretty sure you can handle this. Next part is about addition and the multiplication principle. I have to say this part is super important because even you got into the P4 or P5 or P6 level in the real Olympic math competition, I mean the high level one, addition and multiplication principle will also be tested. Why? Because in later you will find it will have a connection with the combinatrix. So here we go. Addition and multiplication principle is the basic level. Now what is that? Let me show you two summary page. You will understand everything. What is the principle of addition? Don't think too much. Addition, principle addition, just think about when we will use the addition in our real world life. I got several shoes on one side, I got another shoes on the another side. If I want to count how many shoes are there, of course we will use the plus. So in this case, the principle of additions always checking for us from the you want either or. Either or means no matter how you calculate, finally you only have one choices. So I just want to check in how many possibilities do we have. Another one is the principle of multiplication. A great example for that will be wearing clothes. When you want to go out, well, you just have one choices, pick the clothes, and no choices, go out. Are you crazy? No, definitely not. We will do it step by step. Firstly clothes, and then choices. So here we go, I use the word and, or if you want, please remember this step by step. Step by step is the basic meaning of principle of multiplication. When we use it, when we're checking how many possible, the options are there, but all the options, we have to step by step. I need to consider all of them, not just the same, only one possibility. If you understand that, let's check in this question. It's a very typical one. There will be 4 rows between place A and B, 2 rows between B and C, and 3 rows from A to C. When you want to check these questions, how many from A to C, we know clearly there will be 2 ways. Basically, there are 2 ways. One way is directly get there from A to C. How many possibilities are there? 3. And another one is from A to B and then to C. So in this case, how many possibilities are there? I know here is the option for 4. Here's the option to 2. Will we plus or shall we multiply? Here we go, remember what we learned before. When can we use the principle of addition? When we're checking a lot of the options, but finally we just pick one. Another one is we will do it step by step. So of course, that is step by step. Not either or, but and relationship. If you're not so clear about that, let me use another way to simplify. The basic things is the tree diagram. You can use the tree diagram to have a simple show for that. For A, I have 1, 2, 3, 4 possibilities, although they are all going to B. And for each of them, you will get 1, 2, 1, 2, 1, 2, to C, to C, to C. So you will find each of them will get 2 options. Firstly, everyone have 4 options. How many options are there? 4 times 2. So that is the basic explanation for what is our multiplication of principle of multiplication. So 4 times 2, we got 8. Finally, how can we deal with these 2 different? Should we plus or should we times? So in this case, what's the relationship between them? Does that mean when we go A, B, C, and then we go A with C? No. We just pick either or. So finally, we will use the A plus 3. So this question combined the principle of addition, principle of multiplication, 2 of them. So when you plus them together, you will get 11. 11 different rows, our final answer. For the first question, for our addition and multiplication principle. Okay, and then The next one is still the similar, but a more classical type of question. This one is just a warm-up, you know. The road is so easy. Even you don't know, we are testing you the principle of addition, principle of multiplication, you can still do that. However, next question, if you don't understand this principle, it will be super hard. For example, now we got A, B, C, D, 4 S-lets, and they want to get their price in order. A, B, C, D. How many running orders are there in total? So in this question, you really need to understand which kind of principle should we use. Think about, once we got arranged the first place, who will be the first one, and then the next one, and then the third one, and then the last one. Step by step is the principle of multiplication. So here we go. Let's go. Let's check in the first one. For the first option, there are how many possibilities? 4. Everyone A, B, C, D could be the first one, right? Okay, don't tell me that A is the B is the bad one, so B cannot be the first one. Impossible. So everyone could be. However, the problem is, for example, I let B be the first one. Is that possible? We let the B be the second one? No, everyone only have one possibility. So second one, we only have 3 options. Maybe A, C, or D. So second one, I let the C be the second one. C represents cherished. And then the next one, how many options? Only 2 options, either A or C. Either A or, let me write down the possibility and the final answer. Either A or D. So in this case, how about we put in A here? So if this one is the A, we know there are also 2 options for that. Lastly, sorry, we only left which number? We only left with D. So D is the only one possibility. So here we go. When we times everything here, you will find the final answer is just our C, 24. So if you want to solve this question, 2 things you need to understand. Firstly, which principle should we use when we're checking the step by step? So exactly, this one is a principle of multiplication. Secondly, when we checking them in order, is that possible the people be the first one, in the meantime he's the second one, in the meantime he's the third one, in the meantime he's the fourth one? Of course not, right? So each time when we get into the next place, this one cannot be on this place anymore. Okay, got it? And then, once you finish this section, next one is another type of question. It's quite similar. The first one, I can call it as the queuing problem. So we are trying to queuing and find who is the first, second, and third, fourth. Next one, it will be the number. When we're checking the numbers, forming numbers, that is a even more classical questions. 120 different 5-digit number made of 1, 2, 3, 4, 5. What is the 95th number when you arrange them from smallest to largest? Oh, this question I have to see. In the one side, it's easy. Why? It even tell you there are 120. Secondly, what is the difficult part? The difficult part is it didn't tell you 95, and in the meantime, in order, should I really need to listing all the numbers until 95? Which means you need to listing 94 numbers? Of course we can't. We need to use some tips. 1, 2, 3, and then 4, and then 5. For these numbers, if we want to arrange them from small to big, let me ask you a very important question. If I want to arrange them from small to big, I need to firstly arrange which number? Which place? The first or the last place? Of course, we from left to right, checking the first place to make sure it's the smallest one. So the first place is 1 to the smallest one, it has to be the number 1, right? So if it is starting from number 1, the secondly, okay, let me write down. Start from 1 as the first one. Second number, it can have how many possibilities? 4 possibilities. Everyone, listen carefully. I'm not writing down the number here. I'm not exactly writing down which number. I'm writing down how many possibilities are there. Because the first one, I have to pick the 1 here, so there will be only 1 possibility. Second number, how many possibility? Apart from 1, we left with 4 numbers, so 4 possibility. Next one, 3. Next one, 2. Next one, only 1. So if you times them together, start from number 1. In all, there will be 24 possible numbers. There will be 24 possible numbers. How about we starting from the number 2? Do we need to do this part again? Actually not. It's still similar because we are not checking the number, we are checking the possibilities. If you pick number 2 on the first place still only have 1 possibility. Second one still have 4 possibilities. Just among these possibilities, the number are different, but the number of possibilities are the same. So starting from number 2 is also 24 numbers. So you know, from number 3, also 24. From number 4, also 24. Even if it's number 5, they are also 24. But hold on, when you got number 4, have 24. 24 times 4 equals to how many? 96. So, can you tell us what is the 96th number? What is the 96th number among all of the possible numbers from small to big? Yeah, you know, it should be the one. We starting from the number 4. And once we put number 4 here, of course you want to make sure it's as small as possible. We will not put a very big number on the higher place, right? If you want to make sure the number, it should be the smaller one. Next one, you will pick the smaller one. But remember, we already in the end. It should be the greatest number starting with 4, which is our 96th number. So the greatest number from the number 4, the next one we will pick the number 5. And then number 4 already occupied. So number 3, number 2, and number 1. That is 96. What is the little smaller one? A little bit smaller one, 95th one. If I want to change the order, make it smaller, where is the possible? The last, the 4th digit. Why? I told you, this one have 2 possibilities. This number on this place have 2 possibilities. One is 2, another is just 1. So the only 1 possibility is 4, 5, 3, 1, 2. 4, 5, 3, 1, 2. How many of you can solve this question without my help? If you can, I think in the addition and the multiplication principle, this type of question, you don't have any big trouble. Okay? Lastly, what is the total number of all the 3-digit numbers containing at least one number 7? Wow, this question is really hard. It's really hard. Why? Because all the previous question, we know that every number, no matter we're checking the queuing problems or forming numbers, exactly that's the same. But in this one, we are checking at least number 7. What's the meaning of at least? If you joined some competition before, you will clearly understand at least consists of so many informations. Just this little 2 word. At least means what? It could be 1. It also could be 2. It also could be 3. Any other possibility? Oh, sorry, just 3. Because we are only looking for a 3-digit number. Okay? So let's do it step by step. But even when you got this, the 3-digit number, only 1, you still thinking about one more thing. What is that? There are only 1 7. Where this 7 could be put here? The 7 could be put on the ones digit, tens digit, or hundreds digit. Let's check it. It's not so hard. It's still not so easy. Let's check it. 1, 2, 3, 3 digits number. If I told you there's the 1 digit number on the 7 is on the ones digit, so which means the ones digit has to be the number 1, or only number 7, so only one possibility here. And if we want from the left to right, how many numbers left over? Don't forget, we are checking the number from 0 to 9. So 0 to 9, exactly there will be 10 numbers. So I already used 1. Does that mean for the hundredths place that should be 9 numbers? Is that right? No. Why not? Because 0 cannot be the number on the hundredths place. So for the ones digit, it only have 8 possibilities. How about for the tens? Is that the tens digit? I can use also the sevens, because it should be 1 less than the ones digit. The ones digit already use it. Is that true? No. Why not? Because when you solve this question, you will find out, for example, the number, this part, I already take out the number 7. And I left with 9 numbers here. Does the question said I have to use all the different number? No. Which means you can use the repeated number. So is that 8? No, because exactly 0 could be on the tens place. So finally, there will be 72 possibilities. Second one, for the tens digit place. Okay, firstly, let's put tens digit place only 1. Similarly, for the hundredths place, there are also 8. Ones digit, there are 9 possibilities. Times together, there was 72. Finally, let's come into our hundredths digits. I love this one so much. Because if you keep going, you will say, oh, teacher Travis, I know for the hundredths digit, it should be 1 times 8 times 9, 1 times 9 times 8, as we did before. But exactly, in this time, 1 you got 7 is already on the hundredths digit. Do you need to worry about 0? No. You can even write down 700. So all the tens and ones place, the possibility is 9. Finally, you will get 81 on our 100 digits. So how about if we say this number have 2 sevens? In this case, when we say 2 7, you need to combine the 2 digits together. For example, how about these 2 digits 7 are on the tens place and the ones place. So which means tens and ones place, it has to be the 1. How about the ones and tens place has to be the 1. Only one possibility. How about for the hundredths place? Hundredths place. Hundredths place, we have come back to the previous one. Is that possible 0 on the 100 place? No. So although there's 10 number, I deduct 1 more number from that. For the hundredths place, I also need to deduct 1 more, that is 0. So exactly there are only 8 possibilities. How about if this number is on the tens and hundreds? So tens and hundreds, there are only 1. The ones place, there could be how many? Exactly, we can put 9 possibilities here. 9 possibilities. Why? Yeah, it could accept 1 more 0 here. So that will be 9 number. Similarly, for hundreds and ones place, the middle one is okay. I could let the zeros be here. So there are also 9 numbers here. Finally, you know, there will be 1 more. That is a number have only 3 7. What is that? 7 7 7. How many possibilities are there? Only 1. So finally, when you want to find how many was the total number, we are checking all the possibility. We will do what? 72 plus 72 plus 81 plus 8 plus 9, plus 9, plus 1. Is there anyone get a final answer? Yeah, after this long calculation, you will get a final answer is 252. 252. Is that amazing? Is that amazing for this question? It's not so hard, but it needs you checking every digit step by step. And always remember, in our forming numbers question, the number here we put on the little line is not exactly which numbers are there. It's how many possible numbers are there. Okay? So that is our first two parts. Let's have a quick break time for 3 minutes, and then we will come back to the rest of the section. Okay? Wait a minute, I will come back. Okay, everyone, welcome back. You just rest your ass and welcome back to our second section. We will learn something about a little bit difficult, but I have to see it's the really frequent test knowledge point. First one is the maximum and minimum number. What is the maximum? What is the minimum? We're trying to get in forming some numbers to make sure we can get sometimes the greatest, sometimes the smallest number. Okay? Let's check it. First one, a rectangle has a perimeter of 40 centimeters. So what is the maximum area of its area in square centimeters? So we are looking for, I know the perimeter of that. I want to know the maximum area of it. What is the rectangle? I will have four sides. And this one is A, this one is B. So normally one is plus A, B is equals to, the sum of A equals to 40. How can we get area? Just A times B. How could we make sure the area as big as possible? We will try to make sure there's two numbers as close as possible. And what is the greatest situation? Which means this one change it into a square. The two sides are exactly the same. The two sides are exactly the same. In this case, we will get the greatest area of it. So exactly the 40, if I assume this one is a square, that will be each side is to be 10. And 10 times 10, we got 100 centimeter square. Okay, square centimeter. From this case, I wish you can get this important conclusion. It's super useful for this type of question, forming numbers. When we forming numbers, we follow by a simple rule. When the sum is constant, the smaller the difference, the larger the product. Okay? What is the sum? In this case, is a perimeter. And we are looking for what? We are looking for the largest area. Area is the product of two sides. Okay? So we are trying to make sure the difference is smaller between the two sides. And what is the smallest situation? When the two sides, they are exactly the same. Yeah, Jancy, you are right. It's just 100. Okay, let me check YouTube. Anyone got 100? No one? Okay, it's not so hard question. Next one. Later we will review this knowledge point. And firstly is, what is the maximum product of the 4 number cars? Just there's 4 number, 4, 9, 3, 6. Use them to form a 2 digits by 2 digits equation. What is the smallest one? What's the meaning of that? What's the meaning of that? Let me write down. So in the one situation, I will form 2 digits number, 2 digits number. And when we times them together, we got a largest number here. And in another situation, we got 2 digits number, 2 digits number, times together, we got the smallest number. So easy, right? However, there will be one more hidden information. You may not notice that we just call it number cars. The number cars could be rotated. Why? 6 and 9. When 6 rotated, we got the number 9, right? So when we're forming the numbers, if we want to make sure the maximum product, we will make sure there's 2 numbers as big as possible. Firstly, if this number is as big as possible, should we make the which digits place number bigger? 10th place or 1st place? 10th place. Yeah, in this case, that is the basic place value principle. Place value principle. Place value principle is super interesting because in the number theory is also a big part. It can help us to determine the divisibility. But that is not our today's topic. So here we go. We're checking. We will make sure there's 2 numbers as big as possible. They could be 9 and 6. Don't forget, 6 could be rotated into the 9. And for the rest of 2 numbers, it's just the 4 and 3. Does order matter? No, it doesn't matter. So we can directly use the 94 to times the 93, get our final answer. But wait a moment, let me firstly checking all the 2 possibilities and then go back to this question, okay? Another one is for our smallest. For the smallest, oh, Emily, you are here, cool. Yeah, Emily, listen carefully. That is everything we learned before. And 3 and 4 should be the 2 smallest number. We put them here. And trying to make sure there's 2 numbers as small as possible, of course. Well, you use the 9. No, you will definitely not use 9. Neither of it will use 9. We will put 2, 6 here. So finally, when you times them together, the greatest one you can get is 8742. And the smallest one you can get here, it should be 1656. 1656. Okay, that is 2 numbers. Greatest one and the smallest one. Just be careful, there will be some tricky part. Sometimes the number card could be rotated. Next one, find the largest possible product of two-digit numbers from digits 2, 3, 4, 5. Find the smallest product of two-digit numbers formed from the same digits. Be careful, the two-digit number in the two scenarios do not necessarily need to be the same. What is the difference between their product? So actually, to solve this question, we will have three parts. Firstly, checking the largest number. Secondly, checking the smallest number. Lastly, checking what is the difference between them. So when we solve this question, don't forget, we are not just checking what two-digit number is. A two-digit number times a two-digit number. It's quite similar as we did before. So in this case, I think I can move it a little bit fast. I don't need to write down the vertical form for you. So let's do it. For the largest one, we're trying to pick the greatest number on the greatest part. So 4 and 5. The rest 2 is the smaller one. For the smaller one, we are trying to pick the smaller number on the higher place value. Higher place to make sure it have the smaller value here. So what is the smaller number here? As we did before, they are 2 and 3. And the bigger one is 4 and 5. So 2 and 3 we put here. 4 and 5 we put here. When you calculate, the first one equals to 2,236. The second one, you will get 840. Lastly, just minus them together, we can get our final difference. I think this one is not so hard. Just do one more steps. And the final answer here is 1,396. 1,396. That is our final answer. Okay? And we get into our, is that the final question? Let me check. Is that the last one? Yeah, the last one for our maximum and minimum number. This one is slightly hard. It's slightly hard. Why? Because even the previous one, when we said two numbers times together, they are the 2 digits times 3 digits, 2 digits. But in this case, we are not. We are checking our 2 digits number times a 3 digits number. Ideally, 2 digits times 3 digits will look like this one. 3 digits times 2 digits. How could we solve this question? If you keep going your phone, if the two numbers, they have the different digits, that will be super hard. If we didn't solve this question, this problem, this tricky part, we cannot go on. Can you find any method we can make sure the two numbers could have the same digits? And be careful what we're looking for. We're just looking for the product of two numbers is the largest and find that two number. Okay, let me give you two numbers, for example. How about, I just randomly, 23 times 145. Is there any possible we change this 23 into a 3-digit number and make sure we can still get the largest product? It will not influence our final answer. How about we change this one into 230, which means we add one more zero. Why we do so will not influence our final answer. Because when we add a zero, it will actually not influence the previous number. We can make sure the previous number is still the biggest one, so it will not influence our final answer. So let's just assume this one is the 230. This one is the 23. Oh no, not 230. Not exactly 230. Just one number is ending with 0. Another number is whatever you want. Finally, we just need to checking the 2 digits number, with the 4-digit number, but we remove that one more zero. It's okay. We just remove that one more zero. It's okay in the end. So once we understand that, we exactly know, we should put 4 and 5 on this part, and then we will put 3 and 2 here. Finally, 1 here. But is that our final answer? I want to ask you, is that our final answer? So you will find it slightly different. Because in the previous one, it will not influence your final answer, but in this case, it definitely influence your final answer. Why? Because the order is really matter. In the end, you will remove this number. You want to make sure this product as big as possible. You also need to consider about one more thing, which is how could we arrange the order of these two numbers. Here we go. Remember, for the first question, we got the important conclusion. If the sum is constant, the smaller the difference, the larger the product. We can see in which time we will not worry about these two numbers order when they plus together, right? So which means the sum of these two numbers must be the same. However, the product is not the same. In which time we can get the largest one when we make sure the difference is smaller. So when can we make sure the difference is smaller? Is that the smallest case? No, because you will find when you minus it, it's quite big. It's over 800. So when can we make sure these two numbers are as small as possible? The difference is smaller as possible. We will put each of the number as close as possible, and the order is really matter. Okay, and when we do so, we also need to change order for that. 500. We cannot put two numbers here. We will make this the difference as small as possible. The difference as small as possible, we will make this sure the top number as close as possible. There's two numbers as close as possible. So the first one, we have to make sure it's bigger. However, for the rest of one, we will make sure the number as small as possible. So 2 on the top, and then 3 on the below. This one, 0 on the top, 1 below. In this case, we can make sure there's two numbers as close as possible. When we do the calculation, when you really do the calculation, you don't need to do it, because we are not looking for the real result. We're just looking for that two number, and we already got it. But don't forget to remove this 0. Our final answer should be 52 times 431. That is the answer for this question. It's slightly hard because it combines several knowledge we learned before. Okay, let's move on to our today's last part, number puzzle. Okay, everyone, if you joined the SASMO before, or if you join any other math competition, you will find the number puzzle is a really popular question. Every competition will involve at least 1 or 2 questions related to that. So let's check in the first one. We got ABCD plus ABCA plus ACBA, and then we got a DBBAB. You will find ABCA is a 4-digit number. ACBA is also a 4-digit number. However, DBBAB is a 5-digit number. When we found a 4-digit number plus 4-digit equals to a 5-digit number, what can we get? We know there must be involved a number carryover. So in this case, what is the possible value of A? Is that possible A equals to 4? No. If we want to involve carryover, A should be a number at least bigger than 5. Yes, Xiaomi, you are right. Once we know there involved carryover, we also know one more thing, that is D must equals to 1. However, this question is not so nice for us because D only appear once. So when we use this information, we cannot do so. However, let's check it. Is that possible? A equals to 5 A equals to 5, so let's go. 5 plus 5 equals to 10, so we got one more 0 here. You know, 0, B equals to 0, so 1 plus 0 equals to 1, so not possible, okay? A cannot equals to 5. Is that possible? A equals to 6. Let's try it. Okay, everyone, you need to keep trying because in the number puzzle, I can only give you the basic idea of that. And 6 and 6. Here we go. We got, there should be 12. So we know A equals to 6, B equals to 2. Okay? And then, here we go. We got one more number here, one more number here. And then, if we keep going, there involve carryover. One more number here. If we want to make sure A is the 6, C has to be 3. And there will not have any carryover. C is 3. And we know B is 2. 2 plus 3 equals to 5. So conflict, not possible. Okay? So A equals to 6 is also not okay here. Next one. How about A equals to 7? Let's check. A equals to 7, 7, 7, 7 here. B must equals to 14, equals to 4. And then we got one more number carry over here. So B equals to 4, combined with A equals to 7. The C has to be equals to just the number 2. Just number 2. And C equals to 2, B equals to 4. And then in this case, you will find conflict. B cannot equals to 6. So it's also not okay. Tired, everyone? Okay, come on, everyone. We almost the end. You know, just from 5 to 9, we only got 2 more numbers. Is that A equals to 8? A equals to 8, 8, 8, 8. You will find B must equals to 6. And we got carry over here. And then B equals to 6. And you want to make sure 8 equals to A. The C has to just equals to 1. And when you put 1 here, B equals to 6. 6 plus 1 equals to 7. Now, okay, also not possible. In this case, B should equals to 6. Finally, A has to equals to 9. A has to equals to 9, but we check it. Is that true? 9, 9, 9, 9. So here we go, we got 18. And one more number get here. 8, B equals to 8. So there already one more number carry over, so C has to equals to 0. So that we got a 9 here, and then the next step, B equals to 8. C equals to 0. So B also equals to 8. Finally, we got it. A equals to 9. C equals to 0. B equals to 8. Congratulations, we finished it. I know it's really time consuming. That's the reason why in the competition, they really like to test this type of question. Next one, what does each letter represent? Okay, still a number puzzle here, but in this case, I really love it. Why? You will find D plus D plus D, C plus C plus C plus C, B plus B, A plus A. So 3D plus together exactly equals to D times 3. And I got 2. Is that possible it really equals 2? No, it has to equals to a 2-digit number with carry over. So, everyone, what's the number signs? This number could be 12. So, D equals to 4. Any other possibility? No. If you keep trying, there's only one. So, once you got the D exactly equals to 4, and there will be one more carry over here. So, here we go. 1 plus several numbers together is equals to several zero. Is that really equals to 0? No, not possible. So it has to equals to 10. How could we get 3 number times 10? Remember here 3 times c. C has to equals to 3. So 3, 3, 3. C equals to 3. C has to equals to 3, 3, 3. D is 4, 4, 4. And once you know, there will be one more number carry over. When you got a carry over here, it still got a 1. And then, here we go, we got the b plus b plus 1 equals to 7, 1. Is that really equals to 1, which means b is equals to 0, 0? No. Why not? Because if the b really equals to the 0, really equals to 0, there the a, how about the a? You also need to consider about number a, right? The a could equals to how many? The a, is that possible? A equals to, a directly equals to 2? A directly equals 2? No. So if you found the a here directly equals to 2, this number have repeated as the previous one. So in this case, the number of a cannot be 2. A has to involve a carryover. The b must be equals to 5. So 5, 5, we got 11. And then with one more carryover, a equals to 1. 1, 5, 3, 4 is our final answer. Okay, Jancy, you are right. Very good. Okay, lastly, not lastly, we got three more questions. A, B, C, D for this one, y times 4. The question is looking for what exactly the answer for A, B, C, D is that. Luckily, in this case, D, C, B repeated. Now, where can we get started? I notice here, when A times 4 with something maybe carry over, we got D. But in the meantime, D times 4, we got a number with A. Maybe we can start from this point. I think it can help us to solve this question. So when you do the number puzzle, be careful. Is there any carryover? If there is no carryover, that is a good news. If the previous question, remember this one? Remember this one? Why notice it involved carryover? A has to be bigger than or equals to 5. However, in this case, when 4 times A, we don't have a 5-digit number, just 4-digit number, which means it has to be no carryover. How could be a number have no carryover? Means A times 4 has to smaller than 10. It could equals to 8 or 4. So A could either equals to 1 or equals to 2. So that's A equals to 1 or equals to 2. We can check it, right? It will not give us only one number here. As I remind for you. In the final step, D times 4 equals to A. Be careful. 4 is what kind of number? 4 is an even number. Even times even got even times also got an even. So A has to be a even number. 1 over 2. Of course, 2. 2 is the only possibility number here. Well done. Once you found A exactly equals to 2, can you get number D? Number D equals to how many? There are two information you can use here. There are two information. One is D times 4 equals to something 2. Okay? Another is sum A times 2 times 4 equals to exactly 8. Okay? 2 times 4 equals to 8. Remember I told you there are two information. Is that possible? Use these two. Have a double check. 8 times 4 equals to 32. Yes, very good. It's possible. But in the meantime, we got 3 more number carry over. However, we haven't stopped. We will not stop here. B and C are really are also interesting because they repeat it here. C times 4, B times 4. And in the previous question, we know that 4 times 8 just we got D, which means 4 times B, it is smaller than 10. It will not have any carryover. So B has to equals to 0 or 1. 0 or 1. Is that equals to 0 or equals to 1? 0 or 1. Oh, and if you are curious about why B cannot equals to 2, because 2 already taken place by A, okay? Different letter represent different numbers. So once you got B equals to 0 or 1, let's keep going. If we know the 1's digits is just 4 times 8, and we got a carryover number 3, and then 3 times 4, we need to plus the 3, we got the B. What's the meaning of that? Let me write down this step. C times 4 plus 3, we got B. C times 4, it has a even number. 3 is a odd number. Even plus odd, we got must be an odd number. So B has to be 1. Okay? So B has to be number 1. Okay. When you got B already equals to 1, the C is quite simple. Which number times 4 plus 3, we can get several, it's ending with 1. Okay? Or you take this one, it's much more easier. 4 times which one, and with carryover, oh, we better start from this one. So how about 7? 7 times 4 plus 3. You will get carryover. This part is also 7. So finally, the number of A, B, C, D is 2, 1, 7, 8. 2, 1, 7, 8. Okay? So in this question, it combines the odd and even feature. Be careful with that. But I have to see the basic thing, the core part is whether this number involve any carry over. Okay? How about for this one? Refers to the puzzle. Each English alphabet represents different numbers. Find the value of A plus B plus C plus D. Okay, one more question. For this question, it's quite similar because it's given us in a multiplication form. But finally, if you can find A, B, C, D, I'm pretty sure you can find the sum of it. Just get one more step, level up. So how can we solve this one? We will observe it carefully. When B times C, we got something 5. What's the good news for us? The good news is, in this question, it gives us a lot of information. Especially for this one. It's only D we don't know that. Apart from A, B, C, D, we all know that. So B times C equals to 5. 4 times C equals to D. A times C equals to 3. And here we go, you will find a very interesting part. That is, how could we get a 5? If the number is ending with 5, which means it has to be the multiple of 5. If it's the multiple of 5, which means B or C, one of that must be equals to 5. Can you agree with me? It's ending with 5, which means when you times them together, B equals to 5 or C equals to 5. For B or C equals to 5, we can have a check. If you assume B equals to 5, if it's B equals to 5, and then 5 times something equals to something, and then we got C and D. Okay? And you will find C could equals to, how about a big number? C could equals to whatever you want. Just the odd number is okay. not an even number. 1, 3, maybe 5, maybe even 7, maybe even 9, maybe even 9, right? However, you will find 1 times c equals to a 7. Is that possible? The c equals to 9? No. At most, it equals to 7. But is that possible? 1 times c equals to 7, so c equals to 1. I think it's too small. If this one is equals to 1, it could not involve any carryover, right? How about 3, 5, and 7? 3, 5, and 7. If it's 3, if this one is the number 3, you will check 3 times 5 equals to 15, and 3 times here, you will get a number which can give us a carryover of number 4. Is that possible? Several number times 3, and then we got a times 3, ending with a number with 3. In the meantime, carry over 3. No, which means a has to be the 11, right? So 3 is not possible. How about 5 and 7? If that is a 5, if this one is the 5, of course not okay. Each number represents the different number. So the only possible way is c equals to 7. Let's check it. If c equals to 7, 5 times 7 equals to 35. So okay, we will carry over with number 3. And then 4 times 7 equals to 28. 28 plus these 3 more, we will get 31. Yes, here you got a carryover. And then 3 times 7 equals to 21. 21 with a carryover with 3, we will get the 24. Oh my god, 24. Is that possible? No. So, which means there will be one more step, you got it wrongly. Which part you may got it wrongly? Here we go, we know the b equals to 5, 7 equals, c equals to 7. So what is the other possibility of a? What is the other possibility of a? Apart from that, you will got one more possibility, that is, how about a could equals to 0? Not just 1 to 9. A could also equals to 0. So if a equals to 0, and then you will find this part is not, we just simply use the 3 times 7. We will use 0 times 7, and of course, there will be 3. And finally, 1 times 7, we got 7 here. No problem. Without any carryover. So here we go, we will get the a equals to 0. Oh, I cannot change back. And which number I haven't write down? D equals to how many? D equals to we just check it. D equals to 1. D equals to 1. Okay? So D equals to 1. Finally, A plus B plus C plus D equals to how many? 5 plus 7 plus 0 plus 1. You will get the final answer here. It should be 13. 13 is our final answer. Okay, from this question, don't forget the number 0. And similarly, when you got the multiplication, checking whether a number have any carryover is so important. Because time is limited, so I just ignore the c equals to 5, this possibility, okay? You can check it by yourself. You will find there's some conflict. Last question. You got a triangle, a square, and a circle times 7. You got a 4-digit number, 4 square, and a rotated square. For this question, as we learned before, if you found the number have any carryover, you should be careful about this information. That may be the key point for us to solve this question. Is it? Is it? So we can check it. In this one, you got a number have how about we starting from the if this number times 7, so we need to consider about, we know it have the carryover, but at most it can carry over how many? Let's write it down. So for 7, 7 times 1 will not influence any carryover. If it involves carryover, 7 times 2, we got 14. 7 times 3, we got 21. 7 times 4, we got 28. 7 times 5, we got 35. 7 times 6, 42. 7 times 7, we got 49. Okay. I think we cannot accept 47, but let's write it down. 7 times 8, we got 56. 7 times 9, we got how many? 63. So what's the meaning of that? Let's check in the tens digits place. For the number 7, if it want to have any carryover, at most it can carry over 6 number here. It can carry over 6 number here. And that is built on which scenario? Which built on number, that one is 9 times 7. Okay, once you know that, let's check. The first number is 4, which means carry over. Next one is 44. 44. Wow, you already get the final answer. Some of you already get the final answer. Okay, firstly, let me write the answer down. If you can solve it by yourself, it's the final answer for this one is 634. Okay, we will check it step by step. In this case, when we consider about the first 2 digits has to be 44, so which means which number of the triangle, triangle is on which place? The triangle is on the hundredths place. The hundredths place times 7, it has to be the number which one? I just writing down all the possible carryover here. Number 4. Starting with number 4. I just told you it cannot be the 7 times 7, right? Different number. So it has to be the number 6. Once we know it has to be, it is the 42. You know there must be a number with carryover 2 more. From what a number times 8, or we even got some carryover, we can get a 20 something. Do we need to consider about these things? No. We will checking the number is here. So you will understand. The square one have a limited possibility. The limited possibility, it could be only 2. Let me change that color. It only could be the times 2, times 3, or times 4. And then we can get some numbers times 8, and they have a carryover if it's 2. It's the 2, 3, or 4. But you will find, and this number square time it together, it also equals to itself. It also equals to itself. So we can check. We can have a imagine one. If this one is just 2. So 2 times 7 equals to 14. If we want to have a carryover with 2, and it's also equals to itself, it has to be the 22. So which means previously there must be a number with the carryover of 8, but we know it's not possibility. It only could have the positive, at the most, it could only have number 6. Number 6 is the biggest possible carryover. How about the number equals to 3? We're checking this one equals to 3. So 3 equals to 3 times 7 equals to 21. Okay, so you only need how many number to make sure it's carryover? 2 more. Is that possible? Yes, it's okay. How about 4? Yes, it's possible. So we transfer this number into 6, 3, circle, times 7, and then we got And then we got 4, 4, and then this one is 3 once again with a rotated square. Oh, this one is not a 0. This one is something like this, like a circle. Okay? And we got the equation like that. Once we got the equation like that, we only need to consider about the last two. 7 or a number times 7, and we know it has to have a carryover of number 2. Don't forget this point. It has to have a carryover of number 2. Because we just know 3 times 7 equals 21. Some number times 7 equals to with a carryover of 2, I think it's certain. This number has to be the number 4. We just check it. This one has to be the number of number 4. So this one has to be the number 8. And then there's 3 digits number has to be the 6, 3, and 4. So everyone, let's go back for this question. What is the key point? The key point is the carryover. So that's the reason at the beginning I asked you to write down all the possibility of the multiple of 7, checking everything about the carryover. And then for each time, you will consider about, is that possible? Is that possible? And then we will get our final answer. Okay, great everyone. That is everything for our today's lesson. We learned the 4 important part. I know this is a little bit hard because every time you will find a different type of question. So all you can rely on is the basic conclusion I already showed you today. So hope you can understand this type of question. Let's see you next time. Next time is also our last time. We will involve some geometry questions. Okay, see you next time. It should be on our this week, Thursday. Okay, bye bye everyone. That's everything. Bye bye.